So we spent the last 2 days of class working with moving back and forth between radicals and radicals expressed in exponential notation where we have a rational exponents. Remember, rational means expressed as a fraction or can be expressed as a fraction. All right, so there's one big overarching rule. I know that there were like 3 different ones listed on the little worksheet you guys were doing, but the big rule is this idea that if we have the mth root, I usually do the nth root, so we'll do the nth root of x to the m, and we can rewrite this in rational exponent form as x to the m divided by n. So basically our index becomes our divisor and our power, our exponent, stays in the numerator. So this gives rise to all the other rules. If you wanted to have those written down, we had the idea that it's something like the cube root of k could be rewritten as k to the 1/3, because in this case there's an invisible 1 on my k, so we can put that as our numerator, and then we have our index of 3. We also saw a lot of rules that involved using powers and radicals to sort of undo each other. So there were a lot of rules for like the nth root of x to the n. Then if we rewrote that using that first rule, we get this as x to the n over n, which is just x to the 1, which is just x. So most of the time when you see this rule, you won't see these middle 2 pieces. They'll just say, if you take the nth root of x to the n, that's equal to x. And then we have the other way to express these things, which is it really doesn't matter, since radicals and exponents are basically both exponents. It doesn't matter which of these 2 things in the first problem, which of these 2 we deal with first. So it is possible we can take something like this and we can think of it as x to the m to the 1 over n, which would be x to the m inside of an nth root, or we can think of it as x to the 1 over n to the mth, right? So the same thing, if we multiply these 2 powers together, in either case we'll get m over n, but this one is showing us that we could take the nth root and then raise that whole quantity to the nth power. So basically, when you have powers and radicals, it doesn't matter which order you apply them in. So why does all this matter? It matters because we're going to use this to simplify things. Basically, if something is given to us in rational exponent form, it would probably be a lot easier for us to deal with if we looked at it in radical form. And it's possible that it works in the other direction as well. So here's some examples. So one example would be something like 8 to the 2/3. Without a calculator, I would have no idea what this is unless I rewrite it in radical notation. And this is something that could easily be on the no calculator portion of your test. But if I rewrite this, I know that the 3 is going to be a root, the index on a radical, right? And then we're going to have a power of 2. And this is either one of these, whichever one you want. Usually if you're moving in this direction from the rational, right, we're going from the rational exponent to the radical, it almost always makes sense to deal with the radical first, then the power. As we can see in this problem, the cube root of 8 is just 2, and 2 squared is, well, 4. One thing to note in terms of our evaluating these rational exponents. We saw this a little bit with the worksheet as well, especially with our irrational answers, the ones that didn't work out beautifully. If you have something like 8 to the 1/2, we don't know exactly what that is, right? This is the square root of 8, which we could simplify, as you've seen before, to 2 root 2. But again, what the heck is this? This is an irrational number. It does not break down beautifully, so we actually have to type it in a calculator and get an approximation. That's what we use those squiggly things to mean, is like, this is approximately this amount. It's not the exact amount. And that's a really important thing for the next exam, is that I almost always will want you to give me exact answers versus whatever the heck this is in a calculator. that's an approximate answer and not the same and not worth points, especially on a question that's like asking you to simplify. But it is important, in my opinion, that you know what this should look like so that way you can evaluate whether you've gotten this question right or not, if you have an approximation. And this is what that worksheet was trying to get you to do. 8 to the 1/2 is somewhere between 8 to the 0, which is 1, and 8 to the 1, which is 8. So it's somewhere between those two. In fact, we know a little bit more because we know 8 to the 2/3 is equal to 4 because we just did that problem. And we could even say that 8 to the 1/3 is equal to 2, right? Because that's just the cube root. So 8 to the 1/2, whatever the square root of 8 is, this is somewhere between 2 and 4. So let's say 3 point something. We don't know exactly what it is. So anyways, that's one way. If we have a rational exponent and we're asked to, in this case, the instructions would be evaluate a value, probably makes sense, evaluate this expression, to rewrite in radical form. The other way that this can be helpful is going in the other direction, going from radicals to rational exponents. This is essential when you get into calculus. This is how we're going to use the power rule to take derivatives, and life will be super easy. So this on the test would just be a question, for an example, would just be a question like this: rewrite as rational exponent. And I'm getting lazy here, but if I gave you the 5th root of 2x cubed, if I wanted you to rewrite that as a rational exponent, you have 2 ways to do that. One, remember the whole radicand is what's having the 5th root. So if I was to rewrite that, I want to make sure I have some parentheses to say this whole thing is being raised to the 1/5. Or if I wanted to, I could even go ahead and think about all of our exponent rules. That 1/5 applies to both factors. So this is 2 to the 1/5 times x to the 3/5. But in reality, this is probably where you want to go. Just rewrite it with that radical as a rational exponent. So don't go this far, just stop here. Okay? This is also useful when you think about all the simplifying we're doing. If you remember back when we first saw simplifying, let's take, say, the 4th root of x to the 12th power. When we did this at the beginning, right, we had to write out all these silly x's, and there's 12 of them, and I'm bored already, and then we'd circle up, since we have an index of 4, groups of 4 of them, count up how many of those groups were, and some people would forget that we only bring the number of groups out, right? Could be a pain in the butt. But if you rewrite this as a rational exponent, now we have x to the 12/4, right? Power is the numerator, index is the denominator, which is just x to the 3rd. I don't have to do all that business of circling things up. Even if I have an uneven, or something that doesn't divide evenly, the 4th root of x to the 15th power, well, this is, rational exponent-wise, 15/4, which is x to the, and then let's think about our mixed numbers here. This is 3 3/4, so this is x to the 3 times x to the 3/4, because we have 12/4 plus 3/4 is 15/4. So if you rewrite this as a mixed number, we now have the number that are going to come out evenly, and then this piece we can go rewrite back as a radical. It's the same exact answer you would have gotten had you done all the simplifying we did before, thinking about what's how many groups we can pull out. So like I said, it's just division. How many times does 4 go into 15? It goes in 3 times, remainder 3. So we get 3 on the outside, or 3 on the inside, 3 on the outside, right? So just kind of pointing out, this is why that division piece works, and you can use rational exponents if they make you happy. So that's just a little intro to rational exponents and radicals. I'll post this up, and then I'll do another video tomorrow morning going through a bunch of the examples in that worksheet, because some of those get pretty tough. So I'll go through that worksheet that you guys have as take home. for this weekend.